Imagine this: the Burj Khalifa, the tallest building on Earth, 828 meters, 160 floors, cost around $1.5 billion. Now imagine if I told you, what if we had $1 trillion? Not CGI, not fantasy. Real engineering, real materials, real construction, real science. Today, we're going to try building the largest structure in human history using nothing but real-world logic. Let's begin. Start with the current giants. Before we build our monster, let's look at the real kings. Burj Khalifa, 828 meters, $1.5 billion. Merdeka, 118, 678 meters, $1.2 billion. Shanghai Tower, 632 meters, $2.4 billion. These buildings took thousands of workers, millions of tons of materials, and years of engineering. But the shocking part? Even the biggest building today costs only a few billion. $1 trillion is 660 Burj Khalifas worth of money. Choosing the perfect location. You can't just drop a $1 trillion skyscraper anywhere. We need real land, not desert sand collapsing under weight. Real scientific requirements. The ground must support millions of tons. No major earthquake zones. Access to steel, concrete, ports, and transport. Stable climate for year-round construction. Best real-world candidates: Texas, USA, strong bedrock, plus huge land, Saudi Arabia, experience with megaprojects, Australia, stable land, plus open space. Let's pick Texas, because it already handles super heavy infrastructure and has enough land for this monster. Let's design the $1 trillion mega structure. Can we build a 2-kilometer tall building? Yes, using today's engineering methods like mega column steel frames, carbon fiber reinforced concrete wind damping systems, deep bedrock foundations, 150 plus meters. Real engineering papers suggest 2-kilometer height is possible, but insanely difficult. $1 trillion allows carbon nano composites, super steel AI-controlled elevators, internal city infrastructure. We are basically building a vertical city. Real cost breakdown. Where does $1 trillion go? Foundation, $80 billion. Drilling into bedrock, anchoring mega pillars. Super strong structure, $300 billion. Carbon fiber concrete plus advanced steel frames. Elevators plus vertical transport, $50 billion, including magnetic elevators like in Shanghai Tower. Electrical plus water plus sewage systems, $150 billion. You need real plumbing for 2-kilometer height. Safety plus wind resistance, $120 billion. Wind at 2 kilometers height is dangerous. We need dampers, aerodynamic shaping flexible joints. Labor cost, $200 billion, millions of workers over 20 to 25 years. Interior design plus commercial spaces, $100 billion. Because a $1 trillion building can't look cheap. This totals approximately $1 trillion, realistically spent. No magic, no fictional science. Real challenges. We must face wind pressure. At 2 kilometers height, wind can exceed 200 to 300 kilometers per hour. We need aerodynamic design like the Burj Khalifa, but stronger. Earth's gravity limits. The higher you build, the more weight compresses the lower floors. Engineers call this vertical stress load. We solve this using lightweight composite materials, wider base, foundation, internal megapillars. Temperature difference. Top floors and ground floors will differ by 20 degrees Celsius. Requires thermal expansion joints. Construction time. Realistically, 20 to 30 years of continuous work. No shortcuts. Final building specs. With $1 trillion, we can build. Height, 1.8 kilometers to 2.2 kilometers. Floors, 300 to 450 people capacity, 120,000 features. Vertical parks, hospitals, apartments, observatories, research labs, high-speed maglev elevators. A functioning vertical city, powered by solar panels and wind turbines installed on higher levels. So, after using real money, real engineering, and real-world science, yes! With $1 trillion, humanity can build the largest building in the world. But here's the crazy part. We barely used 1 trillion's full power. So here's the big question. What should we build next with $1 trillion? A floating city? A bridge across the ocean? Or a giant artificial island? Comment your idea, and I'll break it down using real science.